Hari. What is the next one? Enthalpy of formation of calcium bromide. Enthalpy of formation of calcium bromide. We have studied about that. Enthalpy of formation of calcium bromide. We have studied about that. Enthalpy of formation of calcium bromide. We have studied about that. Enthalpy of formation of calcium bromide. Enthalpy of formation of calcium bromide, right? Enthalpy of formation of calcium bromide, right? What is it? Formation of calcium bromide. Calcium bromide solid. Formation means standard state again elements, right? Br2 liquid, right? Br2 liquid. So standard enthalpy of formation means a particular compound is formed. A particular compound is formed from constituent elements. Standard enthalpy of formation means a particular compound is formed. A particular compound is formed from constituent elements present in standard temperature and pressure. From constituent elements present in standard temperature and pressure. Calcium exists as a solid at standard temperature and pressure. Calcium exists as a solid at standard temperature and pressure. Bromine exists as a liquid. Bromine exists as a liquid at standard temperature and pressure. Bromine exists as a liquid at standard temperature and pressure, right? At standard temperature and pressure, right? So this is the formation enthalpy of calcium bromide, right? Formation enthalpy of calcium bromide. Right. Pudiliyana calculate the lattice energy of calcium bromide solid by constructing an appropriate enthalpy level diagram. Right. Pudiliana's topic ekak Born-Haber cycle. Right. Born-Haber cycle. Topic Kalyana, Born-Haber cycle. So what do you mean by Born-Haber cycle? It is the enthalpy level diagram, right? It is the enthalpy level diagram. It is the enthalpy level diagram. It is the enthalpy level diagram for an ionic compound, right? Enthalpy level diagram is drawn, right? Enthalpy level diagram is drawn for an ionic compound is the Born-Haber cycle, right? Enthalpy level diagram. Enthalpy level diagram is drawn for an ionic compound, right? Enthalpy level diagram is drawn for an ionic compound as the Born-Haber cycle, right? Liana Bude. Enthalpy level diagram the enthalpy level diagram enthalpy level diagram is drawn. Enthalpy level diagram is drawn for an ionic compound. Enthalpy level diagram drawn for an ionic compound is known as Born-Haber cycle. Is known as Born-Haber cycle. Right. පුතේ calcium bromide solid එකට Born-Haber cycle එකක් තමයි අපි දැන් construct කරන්න යන්නේ. calcium bromide solid එකට Born-Haber cycle එකක් construct කරන්න යන්නේ. Right? Born-Haber cycle එකක්. එතකොට then what are the informations you are given? What are the informations you are given? First එක අපි lattice enthalpy එක ලියාගත්තා, right? lattice enthalpy එක මේ විදිහට ලියාගෙන තිනවා calcium bromide solid dissociate into gaseous state calcium 2 plus and 2Br minus gaseous state. This is delta H naught lattice. Then enthalpy of evaporation that is Br2 liquid is converted into Br2 gas delta H naught evaporation EVP. Then bond dissociation enthalpy of Br2 gas Br2 gas converted into 2Br gas, 2Br atoms, right? 2Br atoms gas delta H naught dissociation D. Then electron affinity එක අපි consider කරා electron gain energy කියලා. So gaseous state එකේ තියෙන Br gas එක electron gain energy 1 electron accept කරලා gaseous state එකේ තියෙන Br gas එක produce කරනවා. gaseous state එකේ තියෙන Br gas එක that is delta H naught electron gain energy gaseous state එකේ තියෙන Br gas එක. Enthalpy of atomization of calcium so calcium solid එක convert වෙලා තියෙනවා gaseous state එකේ තියෙන calcium gas එකට. So enthalpy of atomization we have delta H naught ATM. Then sum of the first and second ionization energies of calcium which means gaseous state එකේ තියෙන calcium atom එක convert වෙනවා කාටද gaseous state එකේ තියෙන calcium 2 plus එකට because sum of the first and second ionization energy of calcium එහෙනම් එතන enthalpy values දෙකක sum එකක් තියෙන්නේ delta H naught I1 plus I2 right? So these are the enthalpy values you are given, right? These are the enthalpy values you are given, right? First and second ionization energy, first and second ionization energy of calcium. Enthalpy of formation of calcium bromide, enthalpy of formation of calcium bromide, right? That is enthalpy of formation of calcium bromide, CaBr2 solid, CaBr2 solid, you get calcium solid Br2 liquid, calcium solid Br2 liquid එක through තමයි you get that. So delta H naught formation of calcium bromide. So these are the informations you are given. These are the informations you are given. So this is what they ask you to calculate. This is what they ask you to calculate. And this is 31 kilojoules per mole. 31 kilojoules per mole. And this is 193 kilojoules per mole, 193 kilojoules per mole, and this is minus 331, this is minus 331 kilojoules per mole, minus 331 kilojoules per mole, and this is 177 kilojoules per mole, 177 kilojoules per mole. මෙතන 1740 kilojoules per mole, මෙතන minus 683 kilojoules per mole, minus 683 kilojoules per mole, right? So these are the informations you are given. So by using these enthalpy values, you can construct a Born-Haber cycle to calculate the lattice enthalpy of calcium bromide, to calculate the lattice enthalpy of calcium bromide, to calculate the lattice enthalpy of calcium bromide. හරි පුතේ. එතකොට හොඳට මතක තියාගන්න. Born-Haber cycle එක start කරන්න හැම වෙලේම Born-Haber cycle එකක් start කරන්න හැම වෙලේම lattice enthalpy එකකින්, right? Born-Haber cycle එක start කරන්න හැම වෙලේම lattice enthalpy එකකින්, right? එතකොට lattice enthalpy එක use කරලා Born-Haber cycle එක start කරන්න. පැහැදිලිද? lattice enthalpy එක use කරලා, right? lattice enthalpy එක through Born-Haber cycle එක හැම වෙලේම start කරන්න. right? lattice enthalpy එක through Born-Haber cycle එක හැම වෙලේම start කරන්න. එතනදී as a first step you should mark the energy axis, right? You should mark the energy axis. This is enthalpy axis. Enthalpy kilojoules, right? This is the enthalpy axis. This is the enthalpy axis. The first of all, enthalpy axis එක, right? Enthalpy axis එක. And first enthalpy axis එක, second එක lattice enthalpy එක. හැම වෙලේම lattice enthalpy එක mark කරගන්න. Suppose lattice enthalpy start somewhere here, right? Start somewhere here, somewhere here, yeah, somewhere here. Okay, there you have the stable compound, that is calcium bromide solid. Right, here you have that stable compound, calcium bromide solid. Okay, calcium bromide solid. And what do you mean by lattice enthalpy? It is dissociated into calcium 2 plus and the 2Br minus, right? It is dissociated into calcium 2 plus and 2Br minus. Calcium 2 plus and 2Br minus. It is dissociated into calcium 2 plus and 2Br minus. Right, I'll take somewhere here. So, you convert calcium bromide solid into calcium 2 plus gas plus 2Br minus gas. Calcium 2 plus gas plus 2Br minus gas. Right. Here calcium bromide solid is converted into this. The process is an endothermic process. It is an endothermic process. A lattice enthalpy is always an endothermic process with a very large value, right? Lattice enthalpy is an endothermic process, which means it's a delta H positive. It is delta H naught positive, right? That's what you should calculate. That's what you should calculate. The lattice enthalpy is a large positive value. It is always a large positive value. It is endothermic process. Endothermic process means reactant absorb energy and convert into a product having greater energy. Endothermic process means a reactant absorb energy and it is converted into a product having a greater amount of energy. That is what you call as endothermic. So our lattice enthalpy, the lattice enthalpy is always a positive value. Lattice enthalpy is always a positive value. Lattice enthalpy is always a positive value for stable compound, right? It is always a large positive value. It is always a large positive value. It is always a large positive value. It is always a large positive value for stable ionic compound, right? For stable ionic compound. Then I can connect all other enthalpies you are given, right? I can connect all other enthalpies we are given and the question for this, right? Balu. Hari budhe balu. Now select anion, right? So here you have the lattice enthalpy as the products. In lattice enthalpy, you have a cation in gaseous state, a cation in gaseous state, and an anion in the gaseous state. You have a cation in gaseous state, you have a cation in gaseous state and an anion in gaseous state. Okay? You have a cation in gaseous state and you have an anion in gaseous state. I choose Br minus, which means the anion at first, right? I choose the anion at first. It is easy, easy, and generally anion should be produced at first. Enam mama Br minus එක මුලින්ම produce කරනවා. Br minus එක මම මුලින්ම produce කරනවා. What is it? එතකොට as a product where you have Br minus, here you have Br minus. හරිද? Check your enthalpy, right? Check your enthalpy values, or whatever the enthalpy values you are given. So like in thermochemical cycle, you should have a common species. Either there has a reactant or product. You should have a common species either that has a reactant or product. It can be a reactant or product, right? So you have Br minus gas. You have Br minus gas. That Br minus gas is produced in the enthalpy of electron gained. Electron gaining enthalpy, right? Enthalpy of electron gain give Br minuses. So Br minus can be produced by using that enthalpy, because I have selected Br minus at first, right? I have selected the anion at first, the Br minus at first. So that Br minus is common with electron gain energy, right? Br minus is common with electron gain energy. So electron gain energy ke as a product Br minus tino, and that process is an exothermic process. That process is an exothermic process. It releases some energy, that is minus 331. It releases minus 331 kilojoules per mole. It releases minus 331 kilojoules per mole. It releases minus 331 kilojoules per mole. It releases because the process is an exothermic process. It releases some energy. And produce this means it is a product. Br minus is a product for the electron gain energy, for that enthalpy, for that definition. It is a product. For that definition, it is a product. So, and it is an exothermic process. it is a product and it is an exothermic process. So product has lower energy. Why? Because it is an exothermic process. Product has lower energy. Exothermic process means a particular reactant releases energy and produce a product with a low energy. That is what you call as exothermic process. What do you mean by exothermic process? Exothermic process means a reactant releases energy. A reactant releases energy by producing a product having a lower amount of energy. A reactant produces a product having lower amount of energy. So it releases energy. That is what you call it as exothermic process. So your product is in lower energy, which means your reactant that is Br gas, Br minus gas is produced from Br gas. Br minus gas is produced from Br gas. So your reactant is Br gas plus electron. Br gas plus electron tamai, you get Br minus, right? Br minus is produced from Br gas. Br gas take one electron by producing Br minus. But here you have a really important point. What is it? Here you have really important point. What is it? 2 Br atoms, which means 2 moles of Br produce 2 Br minuses. Here you need 2 Br minuses. Here you need 2 Br minuses. So 2 Br minuses can be produced from 2 Br atoms. For that you need 2 moles of electrons. For that you need 2 moles of electrons. Right? You need 2 moles of electrons. 2 moles of electrons. 2 Br gas accept 2 moles of electrons by producing 2 Br minus gas. Okay? 2 Br minus gas. And you have calcium 2 plus gas. It is not changed, right? It is not changed, because always you select only one species, right? Always you select only one species for one time, right? One step, right? Change in energy in a one step, change in energy in a one step should be used for one conversion, which means first you select Br minus and you do all the conversion for that. Then only you change, right? Then only you change for the other one. Okay. So here You have 2Br minus gas. You have 2Br minus gas. 2Br minus gas. To produce 2Br minus gas, you get 2Br gas and 2 electrons. And your enthalpy is given here. Your enthalpy for electron gaining, enthalpy of electron gaining is minus 331. Minus 331. Minus 331 kilojoules per mole, twice of that. Minus 331 kilojoules per mole, twice of that. Right. පුතේ ඔය වෙනකන් conversion එක ලියා ගන්න. ඔය වෙනකන් conversion එක ලියා ගන්න. අර මුලින්ම මම enthalpy of lattice enthalpy, right? lattice enthalpy එක මම මාක් කරගත්තා first step එක විදියට. then එයාගෙන් anion එක select කරගත්තා. anion එක select කරගත්තා. right? හරි පුතේ. එතකොට then these two electrons, right? These two electrons accepted from two Br atoms. These two electrons accepted from two Br atoms are released from, right, are released from calcium solid, calcium gas. From calcium gas you produce calcium 2 plus and 2 electrons, right? From calcium gas you produce calcium 2 plus and 2 electrons. So now calcium 2 plus and 2 electrons, calcium 2 plus and 2 electrons should be produced from calcium 2 plus, should be produced from calcium 2 plus, right? Should be produced from calcium 2 plus, should be produced from calcium gas. That is the sum of calcium gas plus 2Br gas. Calcium gas plus 2Br gas. So calcium gas is converted into calcium 2 plus gas and 2 electrons, right? Calcium gas is converted into calcium 2 plus gas and 2 electrons. That process is an endothermic process. That process is an endothermic process. Calcium gas is converted into calcium 2 plus gas and 2 electrons. That is an endothermic process. The energy absorbed is 1700, right? 1700 delta H equals 1700 the energy absorbed is 1740. Delta H equal 1740 kilojoules per mole. It is 1740 kilojoules per mole. And api conversion neka first. Calcium bromide solid eka delta H naught lattice. Delta H naught lattice liyagatta calcium bromide solid ekata you get calcium 2 plus gas and 2Br minus gas. Enthalpy of lattice is always an endothermic process. Enthalpy of lattice is always an endothermic process. It is a highly positive value, right? The enthalpy is highly positive value. The enthalpy value is highly positive value. Enthalpy of lattice. So it is a large positive value. It is a large positive value, and it is endothermic process, which means reactant absorb energy, reactants absorb energy, and the energy of the reactant increased, and the energy of the reactant increased. Energy of the reactant increased. Then that you select the anion, the production of anion, means it is produced from gaseous state atoms. It is produced from gaseous state atoms. The enthalpy associated that process is enthalpy of electron gain. It is enthalpy of electron gain, right? It is enthalpy of electron gain. So enthalpy of electron gain means it is an exothermic process. Your reactant release energy and convert into product. Exothermic process means your reactant release energy and convert into product. That is what you call as exothermic process. And the enthalpy is defined for 1 mole of Br minus. Enthalpy is defined for 1 mole of Br minus. 1 mole of Br minus release minus 1 kilojoules per mole. 1 mole of Br minus 1 mole of Br release minus 331 kilojoules per mole in order to produce Br minus. But here you have two Br atoms, because you need 2 Br minuses. You need 2 Br minuses to produce calcium bromide. It is CaBr2. To produce CaBr2, you need 2 Br minuses. To produce 2 Br minuses, you need 2 Br atoms and 2 electrons. So your enthalpy is defined for 1 mole of Br minus. Your enthalpy is defined for 1 mole of Br minus. Then your enthalpy is defined for 1 mole of Br minus. Then what is it? Your enthalpy value should be multiplied by 2. Then these two electrons gained by 2 Br atoms, these two electrons gained by 2 Br atoms, are produced from the ionization of calcium. These two electrons produced from 2br atoms. These 2 electrons produced from 2br atoms are produced from the ionization of calcium. It is produced from the ionization of calcium. It is produced from the ionization of calcium. And calcium atoms ionization එකේදී produce electrons. එහෙනම් මම shift වෙනවා calcium ගේ ionization energy එකට, right? Calcium ගේ ionization energy එකට මම shift වෙනවා. So this is the summation of first and second ionization energy of calcium. This is the summation of first and second ionization energy of calcium, right? Summation of first and second ionization energy of calcium, right? Summation of first and second ionization energy of calcium. Summation of first and second ionization energy of calcium. Okay? So in that equation you have calcium 2 plus and 2 electrons common with wherever you stop. මෙතනනේ stop වෙලා තියෙන්නේ. එතන තියෙන calcium 2 plus and 2 electrons common වෙන්නේ කොතනද? Summation of the first and second ionization energy of calcium. Summation of the first and second ionization energy of calcium කියන එකේ තමයි ඔයාගේ මෙතන ඉන්න calcium 2 plus and 2 electrons කියන එකේන common විදියට ඉන්නේ. Right? Common. It is in common with this. Right? It is common with this. So how do you produce calcium 2 plus and 2 electrons? Production of calcium 2 plus and 2 electrons. Production of calcium 2 plus and 2 electrons from calcium gas. Production of calcium 2 plus and 2 electrons from calcium gas. Production of calcium 2 plus and 2 electrons from calcium gas. Enang ana production of calcium 2 plus and 2 electrons from calcium gas, and it is a large endothermic process. It is a large endothermic process. Endothermic process means absorb energy. Reactants absorb energy and end up with products with higher energy. Reactants absorb energy. Reactants absorb energy and end up with products with higher energy. Reactants absorb energy and ended up with products with higher energy. That is what you call as endothermy. Enang mama start karnawa from a lower energy to this energy level, right? I'll start from a lower energy level to this energy level because reactant absorb 1740 kilojoules per mole. Reactants absorb 1740 kilojoules per mole. So I'll start from an energy level lower than the energy level you stopped, right? එතනින් start කළා 1740 kilojoules per mole add කරගන්නවා. පැහැදිලිද කියන දේ? Right. පුතේ වෙනකල් ලියාගමු. හරි පුතේ. Now I'll take two bromine atoms. I'll take two bromine atoms, right? Two bromine atoms. Bromine atoms are produced from bond dissociation enthalpy, right? Bromine atoms are produced from bond dissociation enthalpy, right? මේ බලන්න. Bond dissociation, from a bond dissociation, Br2 gas convert into gaseous state bromine atoms. So there you have a bond dissociation enthalpy. So two Br atoms common with the bond dissociation enthalpy. That is the equation, right? That is the equation. You have a species common with this, right? That is the equation. A species, right? You have a species common with this. පැහැදිලිද කියන දේ? So bond dissociation enthalpy එක ඔයා ගන්නවා. Bond dissociation enthalpy එක ගන්නවා. So bond dissociation enthalpy එක you have 193 kilojoules per mole. It is endothermic process. Endothermic process means again it absorb a particular amount of energy. Endothermic means you are increasing energy. Exothermic means you are decreasing energy. So it is an endothermic process. You are increasing energy. කවුද? Br2 liquid එක, Br2 gas එක convert into 2Br gas, calcium ගේ conversion එකක් මේ point එකේදී ඔයා ගන්නෙ නැහැ. calcium ගේ conversion එකක් ඔයා මේ point එකේදී ගන්නෙ නැහැ. ඒ නිසා calcium gas එක මම ඒ විදිහටම ලියා ගන්නවා, right? calcium gas එක මම ඒ විදිහටම ලියා ගන්නවා. You won't get a conversion for calcium, right? Okay, Br2 gas එක, calcium gas එක, right? Okay. Then the enthalpy value is 193 kilojoules per mole. It is 193 kilojoules per mole. It is 193 kilojoules per mole, right? It is 193 kilojoules per mole. It is 193 kilojoules per mole. Okay, 193 kilojoules per mole. Right, පුතේ ඒ conversion එකක් දාගන්න. හරි පුතේ. ඊළඟට අපි බලමු. Okay. Then I will take how Br2 gas is produced. How Br2 gas is produced? Br2 gas is produced from 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 Br2 liquid. Br2 gas is produced from Br2 liquid, right? I'll take one conversion at one step, right? Etakota one conversion in a one step, one conversion in a one step. So you get calcium gas या हम convert कराने Br2 liquid है Br2 gas. So there you have delta H naught. What is it? Br2 liquid, Br gas. So Br gasica, right? Br gasica, atomization, where it is? Bone dissociation, sorry, Br2 vaporization, yeah, sorry, evaporation. Br2 gasica produce होती है ना, right? So here you have Br2 gasica and Br2 liquidica, So Br2 liquidica tamai Br2 gasica produce करने, Br2 gasica produce करने Br2 liquidica, Br2 gasica produce करने Br2 liquidica, enthalpy of evaporation value का endothermic process का plus 31, endothermic process का एक plus 31, it is plus 31 kilojoules per mole, it is plus 31 delta H equal, right, delta H equal plus 31 kilojoules per mole, right, delta H equal plus 31 kilojoules per mole, plus 31 kilojoules per mole, okay, right. So Br2 gas produce करने Br2 liquidica, right, liquidica. Then I'll take calcium gas, where it is atomization enthalpy of calcium, so atomization enthalpy of calcium के as a product you have calcium gas. So calcium gas is common with this equation, and it is also an exothermic process, absorbs some energy from calcium solid, right? So I'll take it absorbs some energy. Absorb some energy, right? It absorbs some energy calcium solid plus Br2 liquid. Calcium solid convert into calcium gas now, that is enthalpy of atomization. Enang enthalpy change එක delta H. Enthalpy change එක delta H equal atomization එක 177 kilojoules per mole, and this place is 0 kilojoules. Why? Because you have calcium solid and Br2 liquid, they are elements. Calcium solid and Br2 liquid, they are elements. Their enthalpy is defined as 0. Calcium solid and Br2 liquid, they are elements at standard temperature and pressure. They are elements at standard temperature and pressure. So their enthalpy is defined as 0. So here you have a zero level energy. Okay, zero level energy. Calcium solid plus Br2 liquid. And again, calcium gasica is common with the atomization enthalpy. Is common with the atomization enthalpy of calcium solid. It is common with the atomization enthalpy of calcium solid. So it is an endothermic process, absorb energy. It is an endothermic process, absorb energy. So you write, you are increasing the energy is increased, absorb energy 177 kilojoules per mole, 177 kilojoules per mole, 177 kilojoules per mole. Delta H calcium solid එක absorb energy 177 kilojoules per mole, right? And the important point here is calcium solid and Br2 liquid, they are elements at standard temperature and pressure. They are elements in standard temperature and pressure, stable elements at standard temperature and pressure. It is defined that the enthalpy of elements at standard temperature and pressure is 0, right? It is defined as the enthalpy of elements at standard temperature and pressure is 0, so that is 0. Calcium solid එකයි Br2 liquid එකයි. පැහැදිලිද කියන දේ? Right. Calcium solid එකයි Br2 liquid එකයි. Okay. Right. පුතේ ඔය වෙනකන් ලියාගන්න. හරි පුතේ. What is the final enthalpy? That is delta H naught F of calcium bromide from calcium solid and Br2 liquid. Delta H naught F of calcium bromide solid from calcium solid and Br2 liquid. Delta H naught F from calcium bromide solid, delta H naught F of calcium bromide solid, it is produced from calcium solid and Br2 liquid. So you have calcium solid and Br2 liquid here, and it is common with this, and here you have calcium bromide solid and it is common with this, and the process is exothermic. Minus 683. The process is exothermic minus delta H equal minus 683 kilojoules per mole. Minus 683 kilojoules per mole. Minus 683 kilojoules per mole. So this is the Bonn-Haber cycle for calcium bromide. This is the Bonn-Haber cycle for calcium bromide. पुढे complete කරගන්න. හරි පුතේ. එතකොට මෙයාට මම හෙසස් ලෝ එක ඇප්ලයි කරනවා. බලන්න. මෙයාට හෙසස් ලෝ එක මම ඇප්ලයි කරනවා. එහෙනම් ස්ටාර්ට් එකයි එන්ඩ් එකයි සිලෙක්ට් කරගන්න ඕන. හෙසස් ලෝ එක ඇප්ලයි කරන්න ස්ටාර්ට් එකයි එන්ඩ් එකයි සිලෙක්ට් කරගන්න ඕන. ස්ටාර්ට් එකයි එන්ඩ් එකයි. හෙසස් ලෝ එක ඇප්ලයි කරන්න ස්ටාර්ට් එකයි එන්ඩ් එකයි. රයිට්. ස්ටාර්ට් එකයි එන්ඩ් එකයි. බලමු. එහෙනම් හෙසස් ලෝ එක ඇප්ලයි කරන්න මම මෙයාට ස්ටාර්ට් එකයි එන්ඩ් එකයි සිලෙක්ට් කරගන්නවා. ස්ටාර්ට් එකයි එන්ඩ් එකයි සිලෙක්ට් කරගන්නවා. ස්ටාර්ට් එකේ මොකක්ද? arrows වල starting points එකතු වෙන්නේ කොයිද කියලා බලන්න. at least 2 arrow බලන්න. at least 2 arrow right starting point. එතකොට arrow එක starting point එක කියන්නේ කවුද? මෙන්න මෙතනනේ. මේ arrow එකේ start එක. දැන් arrow එකක් මෙහෙම ලියන්නේ නැහැ නේද? මෙහෙම අඳිනවද arrow එක නැහැ. arrow. මෙතන තමයි arrow එකේ starting point එක. මේ තියෙන arrow එකේ starting point එක. මේක end එක. එතකොට at least 2 arrow right? at least 2 arrow බලන්න at least 2 arrow බලන්න at least 2 arrow බලන්න ඔයාගේ arrows වල starting points එකතු වෙලා තියෙනවද කියලා. ඒ කියන්නේ arrow එකේ starting points එකතු වෙලා තියෙනවද කියලා බලන්න at least 2 arrow. මේ බලන්න ඕනේ දැන් මෙතන ගත්ත කියලා හිතන්න. හම්බෙන් අපි ගන්නවා. මෙතන ගත්තොත් මේක arrow එකේ starting point එක මේක ඇවිල්ලා front එක නේ. මේ arrow එකේ මේ බලන්නකෝ. මෙයා arrow එකේ head එක මේ තියෙන arrow එකේ starting point එක. එතකොට head එකයි starting point එකයි. head එකයි starting point එකයි. head එකයි starting point එකයි. head එකයි අන්න head එකයි. head එකයි තියෙන තැන ආවුණා මේ. ආපස්සට එනකොට ආපස්සට ඕන ගිහලා බලන්න. මෙතෙන්ට આવොත් starting point එකයි head එකයි. 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 starting point එකයි starting point එකයි. මෙන්න start එක. ඔයාලට පැහැදිලිද කියන දේ? මෙන්න start එක. මේ තියෙන start එක. arrows දෙකක starting points එකතු වුණා අන start එක. පැහැදිලිද කියන දේ? මේ තමයි start එක. එහෙනම් arrow heads එකතු වෙලා තියෙනවා මෙන්න මෙතන. arrow heads එකතු වෙලා තියෙනවා මෙතන. එහෙනම් මෙතන end එක. arrow heads එකතු වෙලා තියෙනවා මෙතන. එහෙනම් මෙතන end එක. එහෙනම් ඔයා මොකද කරන්නේ? start එකේ ඉඳන් end එකට root එක මාක් කර ගන්නවා. මෙන්න start එක. මෙන්න start එකේ ඉඳන් end එකට start එකේ ඉඳන් end එකට root එක මාක් කරගත්තා. මේ තියෙන start එක මේ තියෙන end එක. start එකේ ඉඳන් end එකට root එක මාක් කරගත්තා. මම මේක ගන්නවා root 2 කියලා. right. and මේ පැත්තේ මම ගන්නවා එහෙනම් අනිත් root එක ඒ තමයි මේ root එක නේ. මෙන්න මේ root එක. start එකේ ඉඳන් මේ start එකේ ඉඳන් end එකට අනිත් එක. ඒක මම root 2 කියලා දා ගන්නවා. root 1 එකයි root 2 එකයි. පැහැදිලිද? එතකොට ඒ විදිහට තමයි හෙසස් ලෝ එක ඇප්ලයි කරන්නේ කාටද? බෝන්-හේබර් සයිකල් එකට. පුතේ root 1 එකයි root 2 එකයි මාක් කරගන්න. root 1 එකයි root 2 එකයි මාක් කරගන්න start එකේ ඉඳන් end එකට. start එකේ ඉඳන් end එකට root 1 එකයි root 2 එකයි. මාක් කරගන්න. හරි පුතේ. root 1 එකයි root 2 එකයි මාක් කරගත්තා නම් දැන් ඔයාලට ලේසි. according to Hess's law a roots වල summation of the enthalpies roots වල summation of the enthalpies a roots වල summation of the enthalpies තමයි a roots වල summation of the enthalpies තමයි right a roots වල summation of the enthalpies තමයි equal වෙන්නේ according to Hess's law according to the SS law, right? මෙන්න root 1 එක මම ගන්නවා minus 685 kilojoules per mole minus 683 kilojoules per mole minus 683 kilojoules per mole plus the other one is delta H naught lattice a root එක එච්චරයි equal වෙනවා කාටද මම ඒක lead pen එකෙන් ලියන්නම් minus 683 kilojoules per mole plus delta H naught lattice equal වෙනවා කාටද මේ පැත්තෙන් ඉන්නවා සෙට් එකක්ම 177 plus 177 plus 31 plus 31 193 1740 then minus 331 twice of plus minus 3 twice of plus twice of minus 331 that's all. එතකොට එහෙනම් unit එක ලිව්වා box bracket එකක් දාලා kilojoules per mole right simplify කරලා answer එක ගන්න පුතේ simplify කරලා answer එක ගන්න හරි පුතේ simplification එකෙන් answer එක එනවා. simplification එක through වාට answer එක එනවා. simplification එක through answer එක එනවා. පුතේ මේක අපහැදිලි නම් දිගට ලියන්නද? මේ ලියලා තියෙන මෙන්න මේම දෙයක් මොකද්ද? minus 683 kilojoules per mole plus delta H naught lattice equal 177 plus 31 plus 31 plus 193 plus 1740 plus minus 331 right times 2 twice of that you need take a kilojoules per mole හරි නේද එතකොට අනපුතේ මෙයාගේ simplification එක through මෙන්න මේක තමයි මම මේ ලිව්වේ right දැන් බලන්න පේනවද කියලා right එතකොට මෙයාගේ simplification එක through you get what delta H naught lattice calcium bromide right delta H naught lattice calcium bromide එක answer එක you get 2162 2000 equal delta H naught lattice equal 2132 plus kilojoules per mole 2132 162 හරිනේ 2162 right පුතේ ලියා ගන්න Haribode. My 2010 question number 5A walata 2010 question number 5A walata පුතේ question එක පෙරලා ගන්න 2010 question number 5A right question එක බලා ගන්න හරි පුතේ එතකොට what it is calculate the enthalpy change for the reaction magnesium solid oxygen gas to MgO solid. Magnesium solid 2010 question number 5 part A. 2010 question number 5 part A. 2010 question number 5 part A. Magnesium solid with oxygen magnesium solid with oxygen you get magnesium oxide and you are given this kind of balanced chemical equation, right? This kind of balanced chemical equation. Question number 5 part A. Question number 5 part A. First of all you should identify what is it. Magnesium oxide is an ionic compound. Magnesium oxide is an ionic compound and magnesium oxide is an ionic compound and it is produced from its constituent elements. Magnesium oxide is an ionic compound and it is produced from its constituent elements, right? It is produced from its constituent elements. So it is delta H naught F. It is the formation enthalpy. Producing a particular compound from its constituent elements, producing a particular compound from its constituent elements, that is what you called as enthalpy of formation. So this is the reaction is for the enthalpy of formation, but there is a problem. What is it? In enthalpy of formation, right? In enthalpy of formation or standard enthalpy of formation, it is defined for 1 mole of product. Standard enthalpy of formation, it is defined for 1 mole of products. It is defined for 1 mole of products. Standard enthalpy of formation, in the standard enthalpy of formation, it is defined for 1 mole of products. But here you have 2 moles of products. Here you have 2 moles of product. So it is not the enthalpy of formation. Because of that, I'll consider that as delta H naught reaction, right? Delta H naught reaction, right? Because it is not, right, bond dissociation enthalpy, right? So it is not the formation enthalpy, right? It is not the formation enthalpy at 25 Celsius using the thermochemical data at 25 Celsius, right? And they have not mentioned those enthalpies, right? They have not mentioned those enthalpies as standard enthalpies, but still they has to be standard enthalpies. So it doesn't matter you are using delta H naught or delta H, but I use delta H because they have not mentioned those enthalpy values as standard enthalpy values, right? So you should calculate delta H reaction. So whatever the reaction which is not in our definitions, you consider that particular reaction as delta H reaction, right? You calculate as reaction enthalpy, right? You calculate that as reaction enthalpy. So this is a reaction enthalpy, right? This is a reaction enthalpy. But you should understand this. This is an ionic compound. This is an ionic compound. This is an ionic compound, right? And it's like formation enthalpy, right? Actually, it is twice of formation enthalpy, right? It is twice of formation enthalpy. It is twice of formation enthalpy. So these are the important point you should understand, right? You should understand. It is an ionic compound, and because of this, it is twice, right? It is twice, right? Twice of formation enthalpy. Twice of formation enthalpy. Put it